want to start with going to your world script and going to the ready function there. Here we have worker thread pool dot add group task, and this is kind of where we're gonna start things off. You pass n as the parameters, load and unload chunks dot bind player position. This is the function that we're going to be threading. Add group task takes a function and calls it using threads. And the other thing we're passing in as an argument is loaded chunks dot size. This is going to tell the function how many chunks to work on. And loaded chunks is just an array. It's just the array of the chunks. So loaded chunks dot size tells you how many chunks there are. And worker thread pool dot add group task does return the ID of the task, which we will want to save in a variable for later. Like right now, in the process function, we use it here too, because we need to check if the group task is completed and pass in that ID so it knows which task we're talking about. So basically, this process function just keeps the game loading and unloading chunks continuously by whenever checking if the task is completed. Whenever it's done loading and unloading the chunks, we call wait for group task completion using the same ID, and then we just call load and unload chunks again, basically using the same line that we had up in the ready function. So hopefully that makes sense. And then down here in the actual load and unload chunks function, you can see here's that player position argument that we were binding earlier. And here's another argument named chunk index. This argument actually gets passed in by the add group task method itself. It basically works by, so add group task basically creates a big list of tasks it needs to do, and it determines how many by using this argument here, the number of times to do it. But each task in the list gets its own number. They're all numbered, and it passes in this number here. So at the start of this function, we pick out a chunk by going to the list of loaded chunks and picking the one that corresponds to that number. So none of the tasks will pick the same chunk. Each chunk just gets worked on once. This part isn't too relevant. It was from the original tutorial. It just finds where the chunk is, and if it's out of range of the player, it will move into a new position closer to the player, determined by the load radius. So if it's out of that range, it'll go back to the player, but then it gets regenerated and updated, and it has its chunk position updated. Chunk position and update are also important to note here. We'll be taking a look at those in a moment, but first, make sure that you have function exit tree with the underscores defined to have worker thread pool dot wait for group task completion and then the ID, because this makes sure that the game isn't trying to still do that task and keep doing things when you close the game, so it just doesn't crash and have weird errors when you close it. Now if we go to the chunk script, you can see in ready it will generate an update, and generate isn't too relevant here because it doesn't need to worry too much about the threading, but it is where you define your world generation. But the update function is where we need to be a little more careful. So we start with if mesh instance is null, which basically means if there is a mesh instance, if this chunk has a mesh instance, we get rid of it. We kill it. We call deferred queue_free on that mesh instance, and we set it to null. This removes the reference and the mesh instance. Then we have this other stuff, not too relevant to the threading bit. It was part of the original tutorial. And then we have this part. These commented outlines are sort of what you would basically do if you weren't threading. You add the mesh instance as a child, you create the tri-mesh collision on it, and then you set the chunk to visible. But you can't do that because the threading doesn't like that. Instead, you have to use this call deferred thing. So you take your function and then you do .call deferred, and then you put in the arguments to that function. Is basically how that works. It means that you are calling it at the end of the frame instead of immediately, so there isn't threading problems. Because threads normally can't talk to each other. You have to like specifically have certain moments where you where you collect the information and put it together. And call deferred is sort of the simplest way to do that. So mesh instance create time collision, also called deferred, but then there's this bit which might be not as intuitive. Basically everything in Godot, besides like the really basic data types, like basically everything has a set function. Everything that inherits object, I believe, yes. So our chunks are included in that. So the set function basically just takes the name of a property and what you want to set that property to. It's not that bad, but you have to go out of your way to know about it. So we call deferred on the set function to make this become visible. It's just a slightly more convoluted way of doing whatever dot property equals whatever. Now the last thing that is important to note is this chunk position variable, because it actually has a setter function. It immediately sets itself to the new value, of course, that just makes sense. But then we use this set.callDeferred thing again to change the real position where Godot actually has this chunk placed in the world to this. It's just some math that aligns it to like the grid of the chunks. And then we use callDeferred to make it not visible anymore. And that should pretty much be it. Now, if that's still confusing and you have any more questions, just let us know and we'll try to clear things up the best we can. Thanks for watching and goodbye.